Your textbook has a table, table 3.1, which provides an example of a company with a number of employees and output, and uses that to calculate the marginal product and the average product. We can then take that table and use it to make two graphs that appear on this slide. The figure on the left shows us the output based on the number of workers. Now remember, for this graph right here, we're holding the capital constant, meaning that everything that the company does and all of the equipment that they use is not changing. The only thing changing is the number of workers. So we can trace the effect of the marginal worker, which is how much the input increases as you add an additional worker. So here on the total product curve, the difference between 2 and 3, that's going to be the marginal product. So as you add more workers, initially the output increases. We find that in the beginning it increases fast. So down here it increases fast, it's steeper in the curve, but then over time it's going to start to level off. You can really see that in the second graph when we look at the marginal product here, where the marginal product increases sharply at first, and then the rate at which it increases declines over time as you add more and more workers, but you're holding the capital constant. Remember, the marginal product is the additional output caused by adding an additional worker. So when we look at the marginal product, like I said, at first it rises sharply and it begins to fall. I want you to stop and think about this for a second. Does this seem right to you? It can be tempting to think that adding more workers will continue to increase the production at the same rate, that this total product would be a straight line going up at whatever slope, and then the marginal product would be flat going across. But let's really think about this. We're holding capital constant and really everything else besides the number of workers constant. So in this case, the phrase too many cooks in the kitchen is really coming to life. Now, when I taught at my previous institution, the St. Francis University, which is a small school in Western PA, I used the example of a pizza shop because at St. Francis, there was only one bar and one pizza shop in town. It was located in a very small town. But everyone loves pizza, so I think it's a good example for anyone. So imagine a pizza shop. At first, the owner hires a second worker to join them, and it increases output a lot. So now one can stay at the register and maybe work the room, clearing up tables, stuff like that, while the other one works in the kitchen primarily, instead of having one person run back and forth, taking the order and then going back and making it in the kitchen. Now, adding a third worker can be even better. Now they have someone that can focus on bussing the tables, bringing out food, sweeping up, and then when they're not busy, helping out in the kitchen. It's great. But if you keep hiring additional workers to the same kitchen, soon one will sweep here and there, but then they'll have nothing else to do in between. One will spend all their time at the counter, even when there's no customers waiting. There are only so many pizza ovens and so many dishwashers available for them to work, and eventually too many workers start to get in the way. And that's why we see the marginal product start to decline. Eventually, it will even become negative, as adding too many workers will result in people wasting time and distracting each other. When we say that the marginal product of labor is rising as it increases here from 1 to 3 workers. So initially 1, 2, 3 up here until it eventually peaks at about 20 units. After that point, it continues to increase. These numbers here are positive, but it does so at a decreasing rate. So then slowly you're moving down. Eventually, as you get to 8 workers, their marginal product is only 10 units instead of 20. So here we say the marginal product is falling, and we call this the law of diminishing returns. Now, we also include the average product curve here, which is a slightly different shape than the marginal product curve. We define the average product as the amount of output produced by the average worker. So what we do is we take the total output and we divide that by the total number of workers. So the average product is going to increase as long as the marginal product, this curve here, is greater than the average product. You see here where it crosses the line, that's the highest point of the average product. And then as the marginal product falls and continues to stay below the average product is going to decline. This should make intuitive sense. As you add a number that is larger than the average, it's going to increase the average. So looking at the average daily temperature as we move through the spring and into the summer, each day it's hotter and hotter. It's going to bring up the average. But eventually, and by the time you're watching this lecture. Hopefully, it's fall and the weather is starting to cool down. As the temperature starts to dip into the 70s and the 60s, that's going to slowly bring down the average temperature for the year. That's exactly what we see going on here.